Okay, this video is about piecewise functions, how to evaluate them and how to graph them. So the first thing we need to do is evaluate a piecewise function. So this is what a piecewise function looks like. You've got three functions and specific pieces of each. These inequalities will tell you what piece you're looking at. All right, so don't get overwhelmed, just take one at a time. When you evaluate, you're looking at what you're plugging in for x. So like on A here, f of 0. Well, I'm putting in a 0 for x. So I look at my inequalities. Which of these three inequalities contains the 0? Well, x is less than or equal to -3. Well, 0 is greater than -3, so it can't be in that one. Look at the next one. Is 0 between -3 and +4? Yes, it sure is. Well, then I look at the equation there. Well, this equation just says 3. There's not even an x to plug in. So in this situation, the output, if I put a 0 in for x, but there is no x, it still comes out of 3. Nothing changed there. Okay? So look at B, f of 6. So I look at 6. Where does 6 fall in these inequalities? It's not less than or equal to -3. It's not between -3 and 4. It is greater than or equal to 4. So this is the equation I'm going to use. So I do 3 times 6 minus 2, 18 minus 2, which gives me 16. It's evaluated. Done. Look at C, f of -3. Where does -3 fall? Well, x is less than or equal to -3, so it's this equation. I use the top one. So I put in a -3 for x. -3 squared is 9 minus 4 gives me 5. So that's how you evaluate. Use those inequalities to help you narrow down which equation to plug into. Now graphing. Remember, piecewise function means you're going to be graphing pieces of one or more functions. These pieces are defined by the inequality. All right? So if you follow this system, I know it's tedious, but you can do this. All right? You take one equation at a time. So I'm going to start with the first one. And what you're going to do is you're going to build XY tables. And I would do it this way. X, and then the equation here that I'm going to plug into. Now, look at the inequality. It's an or equals to. That means it's going to be a closed circle. So I'm going to make a mark that it's a closed circle. And it's less than or equal to 1. So 1 is my starting point for this graph. Okay. Well, if it's less than or equal to 1, I have to go less than 1. So 0, -1. And I could keep going. So I'm going to make a mark. I'm going to keep going to -infinity because there's no end to it. I could keep going. I'm only going to plug in 3 points because that's all I really need. So now I plug in the x values into my equation. 2 times 1 is 2, plus 3 is 5. 0 times 2 is 0, plus 3 is 3. -1 times 2 is -2, plus 3 is a +1. All right? That gives me enough to graph this one part of the equation, this one piece, if you will. So come over to my graph, and I'm going to graph 1, 5. So I'm going to put a closed circle, 1, 5. At 0, 3, it's going to cross there, and at -1, 1. So I'm going to draw in my line. Okay. Now, just for the sake of example, I'm going to change colors of pen to keep things straight. Now, the next equation, I'm going to do x and -x plus 4. All right? Look, it's just a greater than, so this is going to be an open circle, and it's going to start at 1 also, but this time it's getting greater than 1. So my numbers are going to go up, 2, 3, and I could keep going. I could keep going to positive infinity. All right? That's what that means. So now I just plug in these x values into this. So -1 plus 4 is 3. -2 plus 4 is 2. -3 plus 4 is 1. Come to my graph. I'm going to graph this. So I'm going to put an open circle at 1, 3. At 2, 2, the line's going to cross. And at 3, 1. And it's going to continue on in this general direction. Okay. Now you look at your domain and range. I'm going to change colors one more time just so you can see what's going on. Now, remember, if you collapse this down, think about what x values are contained by the graph. Well, if I collapse this one down, it's going to collapse here, and it's going to cover all of these x coordinates this way. Over here, if I drop it down, it was open, but it was already closed, so this x coordinate is covered. And this way, it's going to cover this way. So my domain is -infinity to +infinity, going on in both directions forever and ever, amen. my range. Okay, if I collapse it, look, these down arrows are going to cover all the way down the y-axis and all the way down the y-axis until the highest place it gets is right here, okay, where y is 5. So I know that my graph is going to go from negative infinity to a positive 5. And then it contains the positive 5 because it's a closed circle. Therefore, I'm going to use the bracket. Okay, remember brackets and parentheses are important indicators on your graph. All right, that's a piecewise. That's how you're going to approach it. Let's try another one. This one has 3 equations, but don't freak out. It's okay. Let's do one at a time. Okay, let's do the first one. X and x plus 7. This is my y coordinate, basically. And this one, notice, is a less than or equals to, so it's going to be a closed circle, and it's a negative 3. All right, it's less than or equal to, so I'm going to go less than negative 3, so negative 4, negative 5, and I could keep going to negative infinity. There is no end point to this one. Okay, we'll do one like that here in a minute. So now I plug in these values into the equation. Negative 3 plus 7 is 4. Negative 4 plus 7 is 3. Negative 5 plus 7 is 2. This equation just says 5. Well, look at your values though. It starts at negative 3 and it's a closed circle. X is greater than negative 3, but less than 1. So I'm going to go all the way to 1, and it's a closed circle here. So this has a beginning and an end. I don't put to infinity on this one because it has a distinct beginning and ending. Now look at this. I'm going to plug these x values into this equation, but there's no x. So guess what? That 5 just carries all the way down. Okay, so this is just going to be a horizontal line segment. All right, third equation. Where does this one start? It starts at 1, and it's an open circle because it's not or equals to. It's greater than 1, so I have to go greater than 1, 2, 3. I can keep going greater to positive infinity. So this one goes on to positive infinity. Now I plug in these x values. So 1 plus 6 is 7, 2 plus 6 is 8, 3 plus 6 is 9, so on and so forth. Now, I'm going to go back and graph my pieces, starting with this one. Okay, negative 3, 4. Closed circle, negative 4, 3, negative 5, 2. So it's doing this business right here. Second one, at negative 3, it's a closed circle. At 5, negative 3, 5, it's a closed circle. And it's going to stay at 5 until I get to positive, x is positive 1. And then this last equation, at 1, 7, so it's just a little bit off the graph, it's doing this. And to 8, to 9, so it's going this direction, okay? So this graph doesn't quite give me enough space, but you get the idea. Now let's analyze domain and range. Okay, so if I look at the x values contained in my graph, these x values are contained by the red one. The blue one uses up all these x values. The green one does have an open circle here, but it's covered by the blue. So closed trumps the open. So these x values are going to be all good to go. So my domain is negative infinity to positive infinity. All right, range. Let's think about this. What is my range? Remember, the down arrow means it's going to cover all these negative and y values. Okay, and it's going to stop right here. There's a breakage right here. So let's represent that. Negative infinity to 4. It definitely includes 4 because it's a closed circle there. So I'm going to include it with the bracket. Then I'm going to jump to y equals 5. Look, I have this segment where y equals 5. It doesn't go anywhere. It just stays there. So it's going to be bracketed on both ends because both ends are colored in. Then it jumps up here where y was 7, and this is where y is 7. It's open circle, though, because it was just greater than, so I'm going to put a parenthesis, and then from there, it just continues on and on and on. So that would go on to positive infinity. All right, so your range could be broken up. Your domain could as well. In this case, this is how it turned out. Let's try one more example. So x and 2x plus 4. This one is going to start at negative 3 with a closed circle. X is less than or equal to negative 3. So I'm going to go less than negative 3 to negative 4, negative 5, on and on and on. Now I plug these values in. Negative 3 times 2 is negative 6 plus 4. It's negative 2. Negative 4 times 2 is negative 8 plus 4. Giving negative 4. Negative 5 times 2 is negative 10 plus 4 is negative 6. Okay? you want to, you can go ahead and graph this, or you can wait to the end, whatever floats your boat. Okay, so there's where my line is going. And oh yeah, this one's going on to negative infinity, right? There's no boundary at the end of this. Now, notice this one is x squared. Remember, x squareds are parabolas? So when you see these, you need to make sure you present enough points in your t-table, sometimes 3, sometimes 4 or 5, until you begin to see some values repeated. Here's what I mean. I'm going to start it at -1 because that's what it says. And it's going to be an open circle because it's greater than. Then I'm just going to go greater than -1. I'm going to start with 4 points and see if that's enough before I see a repeat. So watch what happens. -1 squared is +1, -3 is -2. 0 minus 3 is -3. 1 squared is 1, -3 is -2. 2 squared is 4, minus 1 is 1. Now notice my y value is repeated. I need that to show the quadratic shape of my graph. So if you have a quadratic, you need to plot as many points as it takes until you see the shape. Usually 4, sometimes 5. Do whatever it takes to get it done, okay? Then we just plot it like normal. So -1, -2 is open circle. 0, -3, 1, -2, and 2, 1. And it's going to continue on. You can see the shape there, that quadratic shape is happening. All right? Let's talk about domain. Look, there's a closed circle here, and it goes on to -infinity this direction, right? There's an open circle here, and all these x values are then covered by the blue graph. So my domain would go from -infinity to -3. It includes that because it's closed. Then it jumps over here where x is -1, but it's not included. It's an open circle. And then it continues on to infinity. Y values. All right, look at my y values. These arrows, remember, they're also going downward. -infinity, going. Stops here. However, look at the blue graph. It carries on. These other y values keep on going. So these are going to be all covered. So it's going to be -infinity to +infinity. So in this case, you had a discontinuous domain, but you had a continuous range. Every graph is going to be different on that. All right, in your notes, I want you to try to do this one on your own. We're going to start here in class. Make sure you bring questions with you. I know there's a lot of steps, but you can do it.